The histogram shows the scores of students in a mathematics test. Use a histogram to copy and complete the table below. Estimate the proportion of students who scored at least 33. Use the data in the table to estimate the sample mean and the sample standard deviation correct to fully significant figures. Does the histogram model a normal distribution with a mean and standard deviation calculated in part C? So basically here we've got a histogram of scores and we have to find the frequency. Now, so in order to do this, we need to use the idea that frequency density is equal to frequency divided by the class width. We've already got one value given to us. So frequency is frequency density times the class width. So for the first value, between 20 and 25, we got a height here of the bar of 0.6. So the frequency density is 0.6 times the class width, which is 5, which gives me 3. We don't need to do the next one. Put that in the table. The next one is this one here. So it's going to be 7 times my class width of 2, which is going to be 14. Next one is going to be 9 times my class width of 2, which is 18. And the following one is going to be the 4 times my class width of 3, which is 12. And the last one is going to be between 35 and 40, which is going to be 0.4 times 5, which is equal to 2. If we add these up, we get 60, so there are 60 students altogether. So the number students who scored at least 33 is there, so it's 2/3 of that, so it's 2/3 of 12, plus the 2 that I have here, which gives me 10 students. So the proportion will be 10 out of the 60 altogether. As a decimal, that's 0.1667. Right, so now we need to calculate the sample mean and standard deviation. So taking down the class widths and then writing down the frequencies from the table, just write them as a column. Then we need to find the midpoint of each of these, so that's going to be 22.5, 26.5, 29, 31, 33.5 and 37.5. The sample mean is going to be sigma fx over sigma f, but before we do that, let's just go to our calculator. So going to the calculator, so here I'm using, okay, so from this I'm going to take, so I've put the data in already. This is x, this is f. This is the midpoints, these are the frequencies. Normally it's best to put the cursor here, and then just do menu, number 4, statistics. You should learn how to do this on your own calculator. One variable statistics, forget about that one. And then change these to x and f, and it will put the results in the first available space. Okay, so here I have the mean is 30, the sum of fx is 1,800, the sum of fx squared is 54,595, and the standard deviation is the first one I want. This is the sample standard deviation, which is 3.18. Now in the exam you're probably just going to write those values down, but in order to put some working out in, you've got 1,800 over 60, which gives you 30. The formula for standard deviation is this. Given the variance on the exam script, just remember you need to take the square root and change the ends to sigma f. Putting in those values from the calculator, you probably won't do this in an exam because you probably won't have time. Okay, and then that gives an answer of 3.1756, which is 3.18. Now, the histogram shows that the distribution is, now you only probably have to write one of these down to get the mark, has a rough bell-shaped, is approximately symmetrical about the mean, which is 30. It's only approximately. Or you can write down that all data is approximately within 3 standard deviations of the mean. Okay, so therefore the histogram models a normal distribution with a sample mean approximately 30 and a sample standard deviation of approximately 3.18. Use the model to estimate the probability that a random selected student scores at least 33. Compare your answers with part B. So let X be the random variable, the score of a student. So X is normally distributed with 33.18 squared. We want the probability that X is greater than 33. So go to your calculator, select a calculation mode, okay, and then do menu, probability, 5 distributions, and you do the normal CDF. Change that to 33, and the upper bound, just put a large number in. I'm going to put 9e, so 1,000 will probably do it as well. Okay, these need to be changed to 30 mean, and the standard deviation is 3.18. Press OK, and you get your probability here, 0.1727. So I like to draw a little diagram to show it. Okay, so this area here is 0.7273 from the GDC. If we compare that with our answer to part B, which is 0.166, we have agreement to 2 decimal places, so therefore it's fairly similar. So it's very similar to part B. Right, the last part. The students are then given intensive classes, retake the test. The teacher says the students have done better than the worldwide mean for this test, which is 32. A random sample of 12 students are selected. The average of the scores was 33.5. Carry out a hypothesis test at the 5% level to investigate whether the mean score is as high as stated. You should use the following hypothesis. H0, mu is 32. H1 is mu is 30, greater than 32, where mu represents the population mean for all students taking the test. You should assume the population is normally distributed with a standard deviation of 3.18. H0, mu is 32. H1, mu is greater than 32. It's a one-tailed test. You need to state that at the 5% level. And we're going to use the distribution that X bar is normally distributed with 32, 3.18 squared, with n students being selected in this case, which is 12. There are 2 ways to do the test. Method 1, you calculate the test statistic. So you calculate a value of z using X bar minus the mean over the standard deviation over square root of n. So it's going to be 33.5 minus the population mean 32 divided by 3.18 times divided by the square root of 12. That gives 1.6340, which is 1.634. You can draw a little diagram, so it's upper tail value. So to find the critical value of z, if you go to the calculator and then do menu, 5 probability, distributions, and inverse normal, because you want the area. So we want to upper 5%, so that's a lower 95%, so 0.95. These 2 stay the same as they are, 0 and 1. It gives you 1.645. Okay, so we will reject H0 if it is in this area, but we've already calculated our value of Z. That's going to be somewhere over here, 1.634. It's only just less. Okay, so the conclusion is, as 1.634 is less than 1.645, we do not reject H0. Method 2 is using X bar is 32, 3.18 over 12, and calculating that X bar is greater than 33.5 using the GDC. So we go back to the GDC menu, number 5 probability, number 5 distributions, CDF, and we want that to be 33.5, upper bound to be infinity, so a large number. Oops. So, or you can put 1,000 in. The mean is 30. Population mean was 32. The standard deviation, you have to be a little bit careful, is 3.18 divided by the square root of 12, because there were 12 in the sample, and that gives a p-value of 0.0511. Okay, as 0.511 is greater than 0.05, we do not reject 80, and we say that the teacher's claim is not significant, it's not true. Okay, this has been a video to show you how to do an extended response problem in a statistics paper. I hope you've understood, and I thank you very much for watching.